So here it is. So there's your theorem. All right. So how is this one a little bit different? Here's my chant. Right. For sine is sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. That's pretty much what it is, right? For cosine is cosine, cosine, sine, sine. This is sine, sine, cosine, cosine, sine. So just make sure you do that. The only difference is the sign always agrees with their signs. Okay, so if it's a plus, it'll be plus in the middle. Minus, minus. All right, pretty simple. I highly recommend you to chant it over and over and over. I know it sounds a little dumb, but you will remember it. All right, so now we're gonna find the exact example two. We're gonna find the exact value of this angle right here, which we do exactly the same way as what we did earlier. All right, we start with the expression itself, and we try to put the sign first, and then the two angles that will either add or subtract to it, right? So, but we know that we both have to have a 12 underneath it, right? So we need to figure out 19 and whether we're going to use subtraction or addition. In this case, I'm going to use addition. Not to say that addition is the only way to go about it. You could have used subtraction, figure out what are the two good numbers. Well, 19, what are my two good numbers with 19? Well, I'm going to start with 13 and 6, okay? There are a bunch of different numbers, but you know, you got to be smart about it. I mean, you're not going to go 1 and 18 and get it all the way up there because 1's not going to work well. So I just started out throwing random numbers. So I know 13 over 12 is really not a special number. 6 is good, but 13 is not going to be good. So I go down my list and then I go, well, 4 is a good. 4/12 is 1/3. That is good. But 14 over 12, I've never seen a 14 over 12 even if you reduce it to 7, 6. Yep, never heard of that part. But I do hear about 16 and 3 because 16 over 3 is 4/3. 4 pi over 3, I know that one is a special one. And 3 over 12 is definitely a special one because that's going to reduce to pi over 4. So these are good special angles. So how do you remember? Anytime you reduce it, you want to be able to get that special right angle, the ending of the special right angle. And I'll show you guys that maybe another time right here. Okay, but for now, we know that this is going to be a good one right here. 4 pi over 3 plus pi over 4. These are all good angles. Generally, if the denominator ends with a 4, generally, you're going to have that as a 45 degrees. So that's a good term. Generally, if it ends with a 3, not always, but let's just say if it ends with a 3, generally, if you go 3 times 60, that's 180. So 3, it's going to match with the 60 degrees. So that's kind of how you can go about doing it. And 6, if it has a denominator of 6 too, you can probably do that because that might be a 30 degrees, right? So try to look for denominator that's 3, 4, or 6, okay? And it doesn't work out all the time, but generally 3, 4, and 6 as your denominator is usually a good one. So write that down. Mr. Lee, how do you know this right here? Generally, I'm looking for 3, 4, and 6 as my denominator because those if you look at the unit circle, the special right angles are always ending around 3, 4, and 6 as the denominator for the angles. All right, so which one do we apply? No, there's another typo here. It's applied the sum formula, not the difference. It's the sum formula. So cross this out. Another typo right here. It's called apply the sum formula for sines. All right, so it's sine, cosine, cosine, sine. Right? Look at this right here. And then it always follow the same sign. Remember, this is a sum, so this is going to be a plus, right? Not a difference, sum. So that's going to be a plus. All right, so now we just go and put these angles in, right? So 4 pi over 3, pi over 4 here, and then 4 pi over 3 again, and pi over 4. Okay, so now guess what we're going to do next as step 2? we're going to use our special right angle triangle to work this out. So we're going to draw this out. 45 degrees is the green angle, which is pi over 4. 1 radical 2. Pi over 3. Why did I put pi over 3 here? Well, think about it right here. This is 0 degrees all the way over here. If it rotates, the terminal side rotator is pi, and then you add pi over 3 to pi, you'll get 4 pi over 3. So that's how you know this is it. Otherwise, you can memorize it. All right, so this is a special right angle. It's a 30, 60, 90. So radical 3 is going to be here, but it's going to be negative because it's on the third quadrant. Anyway, this should be old news right here. Step 3, evaluate trig expressions. So now let's evaluate this. Sine. Sine's going to be negative pi over 2 for this angle right here, this red angle that we have. All right, so then we got 45 degrees, so it's radical 2 over 2 for cosine, radical 2 over 2. And then we put down that plus sign, and then we got cosine of this angle right here. So the cosine of this angle is negative 1/2, so we put negative 1/2. And then radical 2 over 2 for sine of 45. Bam, done. Multiply straight across. You got radical 6, so negative radical 6 over 4 here. And this is going to be negative radical 4, negative radical 2 over 4. And then you add them. And when you add it, you just add the numerator and keep the denominator same. So here's how you would have added. Okay. So there you go. Pretty easy. Okay. We have one more practice problem for today, and then you practice. All right. So here we go. Press pause. Go ahead and try to do this practice problem 2. Pretty much you're using this formula right here. You're going backwards. So I'm telling you right here, is find the exact value. It's giving you the right side. You try to make it so that it becomes the left side, and then evaluate it there. Okay, so we're kind of going backwards. See how these right here are not good angles? They're not special angles. Press pause and think about it. Try to use this formula before I move on. Okay, I'm assuming you did it. All right. So, cosine, cosine, sine, sine. So it's definitely not this. It's not the sine function. This is cosine, cosine, sine, sine, which is the cosine. It's this. It's the cosine function for yours, right? So remember cosine, cosine, sine, sine. Look back in your notes in the in the beginning when I did it. It's cosine, cosine, sine, sine. Remember, cosine is always opposite here. So it's going to be a cosine alpha plus beta. All right, so it's going to be cosine alpha plus beta. My alpha is the first degree angle, and then the second angle. So that's how I got that. Well, when you add 40 plus 80, that'll give you 60. So cosine of 100, sorry, not 60, 120. So 120 is a special right angle. So when you draw your unit circle, it's going to be in the second quadrant, and that's a 60-degree special right. So it's the second quadrant. Cosine is going to be negative, and I know that 120 degrees, it's 1/2, so it's going to be negative 1/2. All right. Make sure if you don't quite get this right here, just draw your special right angle. It'll work out. There you go. Good luck, you guys.